I'm going to play you AI music. I'm not sure if you've all kept up, if you've been following it, but what I'm trying to show you here is it was really shit for a long time, and it's got a lot better in the last 2 years. And it seems to be accelerating through a whole series of breakthroughs. And it's not just us in the music tech industry who are doing it. The tools we use are exactly the same tools they're using in self-driving cars. It's exactly the same tech that they're using for all of the other things. We just ride along. As long as you're good enough as an engineer to understand what the hell those guys just did, you can take it and apply it to your domain. It's all shared problem space. We actually treat music as images, and all the work that people are doing in image recognition is the same. We inherit all of that tech. So we're going to listen to a whole lot of music, and some of it's going to be really cool. A lot of it will be shit.
Should we make them guess? All right, so we're going to play what we think is the first proper record.
First one that generally regarded as the first algorithmic song.
This is how we go.
And I'll see how long the audience can stand to listen to this. So this is a Markov chains. So Markov chains is a very old technology where you can take a whole lot of data, mainly sequences, and you can use it to predict. Given a lot of this is sequence prediction, music's a fairly sequence prediction thing. When I play this note, what note's most likely to come? And if you take a whole lot of music and you pass it through Markov chains, you can develop the probability of every note following every other note in a sequence. And you can make music, or you can make something that sounds like music. And this doesn't sound like music, but it kind of does.
Yeah.
The very first, 1959.
I think it's worth noting, though, that when the math existed for... Can you hear that? I think it's plenty loud. Like, it's not the most awesome. But as soon as the math existed to make computers work, there were people working on, can we make music with computers, right? Like, the AI problem is as old as computers.
And what's missing there, that it sounds kind of music-ish, but there's no localized structure, there's no repeating patterns, there's nothing that we would define as being melodic. It's just making stuff that's kind of sound. And if you try really hard, it can make sound. 1989, the first neural net has a go. So Markov chains are considered old school machine learning. This is at the very start of, someone goes, hey, neural nets could be cool. So neural nets are a deep learning model that are inspired, they're not like our brains, but they're inspired by our brains, as in they're kind of analogous to how the brain works with synapses connecting and passing messages and storing potential across nerve endings, all of that stuff, in a very simple way. This is the first neural net version. So this guy's taken Bach music, trained it on that Bach music, points it at us and says, play something that sounds Bach-like. And the big breakthrough there was immediately, you can hear local structure. It's starting to sound like music. You're not Turing on this, but it's starting to sound like music.
But if you played that underneath, like, you know, some dance scene in a period movie, maybe you'd buy it.
That's 1989, and then 1994, Markov chains are revisited, and an artist in the US, David Cope, had the idea of, well, maybe if we enforce rules, and this is the very start of the early, the battle between supervised and unsupervised learning. Supervised learning being, well, we already know some of the rules of music. You should play in key. You know, we should understand notation. Let's build those rules into Markov chains so it sounds a lot better than it did before. So this is the first of those attempts. Trained on a whole lot of Chopin. So, getting better. 2002. The first LSTMs. LSTMs are a special type of neural net that was developed around the same time. Again, the first time someone goes, hey, why don't we have both short-term and long-term memory, which is what LSTM stands for. Why don't we try and do it with music? Like weeks after someone discovers it, someone has a crack at music with it to see, is this how we did it? Is this the way it works? And he's a famous guy. Doug Eck, 2002, he goes on to be the head of the Magenta project at Google Brain. So he's regarded as one. This is 15 years later. He joins Google, and he's one of the leaders of the field. And for the first time, you're getting longer repeating patterns in blues. 12-bar blues is a way to show that it can circle back on itself. It understands those things. No one has been able to get music to repeat like this before LSTMs. Jump forward to the neural net era, 2016. And a lot of you probably have heard this one. So this is the famous people as well. This is the Sony CSL team in Paris who released a song called Daddy's Car. And I'll play it and then we'll chat it. Oh, no, you give context. No, you give context.
All right, so show of hands, have you heard of Sony CSL? Okay, so inside of Sony, there are two research and development teams. One is a big R&D team that takes requirements from their product org. Hey, we need a faster DVD player. We need a VR headset for PlayStation. We need a mobile handset. We need something for our mobile devices, right? All coming out of iterating and improving on products they already have existing in the market. And that's like 1,000 people. Over here, they have one team, CSL, that doesn't do that. They take no direction from the rest of the company. They could care if their stuff becomes Sony products. They only create interesting IP and do research. And that's a 30-person team of largely PhDs located all around the world. That's Sony CSL. The guy who was running that on the music side, we'll talk about what happened to him in a second. So Francois Cachet is the guy's name. He is an elite jazz guitarist as well as one of the world's leading researchers in AI and machine learning around music. And they took a bunch of LSTM networks and a bunch of other rules-based AIs and trained them and asked them for different pieces of a song, took those out from a compositional standpoint, and then combined them, including lyrics, and combined them with human beings into this song, Daddy's Car, with the idea of let's make a Beatles song. This is human beings rendering and synthesizing composition from AI. This is not like push a button and the computer spits out this fully formed stereo master. But to Stephen's point, getting a lot better.
But at some level, kind of cheating. It feels like it to me anyway. That's right, there you go. So this gets into a really interesting discussion amongst the tech people of, is that an AI song? Like, humans performed it, humans sang it, they played all the instruments. Where do we draw the line? And AI wrote it. Is that enough? So is that the first hit? When is the point that we say, yeah, an AI did that? Does an AI have to sing it, play every instrument for it to be the first song? Then there was a land rush. IBM, as they love to do, quickly on the back of that, started to release their own music from Watson at the same time.
So my favorite thing about that, before we play this one, my favorite thing about that one is the comment. Can you guys read the comment? Yeah. Go back a screen. So the comment is, now we need some vaporwave. So everybody knows what vaporware is, right? Vaporware is when you have like a really awesome slide presentation and you're like, and then it's going to do this, it's going to do this. And somebody goes, okay, cool, demo it for me. And you go, oh, well, we're still working it out. We're going to get there. And it's the idea of pitching and presenting software that doesn't yet exist. No one really knows on this track whether or not this is AI composition, AI synthesis, humans edited copy and paste of AI composition. There's a bunch of things about how this was created and by which method that are still currently unknown. The longer things remain unknown in this category, you be the judge.
Yeah, and it's Watson, which is notorious in our space for being great marketers of what AI is. But generally, Watson's done a lot of work in text analysis and things like that. So this was a bit of an outlier for them to quickly turn to music on the back of Sony's. And Bob knows more about this next track than me.
So this is Alex the Kid and IBM Watson, where Watson did sentiment analysis and social media analysis, and they used Watson and for image recognition, social media analysis, and sentiment analysis to create the themes and topics of this song.
We were two dumb kids, full of grand ideas. We knew this would end from the start. It's not easy. No, it's not easy. It's not easy.
So this blurs the lines even more. Is this an AI song? They didn't even write the music with an AI. They came up with the idea for the song with an AI. I say no, but still.
Now, A&R people in the room? Okay, one. So if you use an AI to give you themes and topics around what you're composing, is it any different than typing half of your lyrical phrase into Google and seeing what the suggested completions of that phrase are, which, don't front, is like a major lyric writing tool, right? Is that AI? Right. Effective.
And this was the thing that got me back into neural nets, Wavenet, which is Google's stuff. They've been working on voice recognition. Voice recognition, it turns out the best way to do voice recognition is to be able to do voice synthesis and generation, which is at first feels a bit counterintuitive, but once you learn it, it's such a beautiful idea. The way we understand something is we first have to be able to create it. And they developed two neural nets, one that can create voice, and the other one that can tell the difference between voice and non-voice. And they just keep iterating until they get it right, which is a beautiful idea, that generation is understanding. And they were the first to work with raw audio. Everything you've seen up until now has been symbolic notation of music, using MIDI or some other feature representation of audio, but completely ignoring the raw audio. These guys are working with nothing but raw audio. There's no concept of chords, there's no concept of music notation, this is just straight audio. Software listening to raw audio. And we go back 30 years. So it sounds like crap. It was very exciting for everybody in music, that perhaps now we can start to understand it the way that humans do it.
All right, so everybody is following this, the difference between this and the previous stuff, right? So this is a big training set of files that have no metadata attached. If you were to dump them into your iTunes, they would just be 1.mp3, 2.mp3, 3.mp3, no descriptions, no music, no MIDI data, nothing, right? Just files. And the computer listens to those files and then creates new music the same way a human being would, by having heard it and then trying to contribute and play on its own.
And if you go to wavenet.com, which I recommend you do, and listen to the voice that's there, it is now state of the art for voice recognition, voice generation and synthesis. So, and that's obviously a huge battle. And the reason most of those guys are working at DeepMind in London is on voice. You can imagine the meme in the valley is that voice is the new UX, and whoever owns that can basically get rid of everybody else. That if you can be That's why Siri and Alexa and Google Now, or whatever it's called today, they are the future UX. But it turns out doing that's really hard. And they have the synthesis and recognition working really well now. But what we don't have is this next problem. Someone I met before we started to talk about it was understanding what the hell people are saying. Our language is not as highly dimensional as music. Language itself has many meanings. When we say certain things, we don't obviously say what we really mean. Understanding the layers of complexity in language is still an open problem. This was the best version. So the other cool thing about the Wavenet is they open sourced it so everyone could download it and have a go. And someone trained it on... This was generally regarded as the best sounding Wavenet, which is still pretty shit.
Although this is better than like a couple of Lou Reed records that came out in the 70s.
I won't torment you anymore with that. 2017, this year. So the big problem with that approach is it's too early. It takes nearly 2 weeks to train any size model, which means you can't iterate very quickly when you're using raw audio. So we're waiting for the next generation of processors to arrive so that we can start to work in raw audio. But there's been lots of breakthroughs from that. So the Google team went back to symbolic notation. They started to use their RNNs could they start to learn music without any assistance but from notation? And they developed their own feature representation. It's kind of like a pianola, like a piano roll, or a Turing tape, if you know what those things are. So they're not using standard MIDI, they're converting it to try and actually feel like, they describe it as, their feature representation is like looking over the shoulder of someone playing a piano and watching what they do. So this is not a human performing this is AI performing this, which was a big breakthrough. If you're a musician, you can hear how much more expressive it is than the other music that came before it. And then 2017 also, a startup that we worked with in LA called Amper have raised the bar again, and they're continuing in the Sony CSL tradition, where they are doing supervised stuff. They encode as richly as they possibly can the rules and laws of music into the software itself. They go and get professionally, Bob could talk more about what they do, professionally record all of the loops and samples that they can, and they're targeting, I'll let Bob know a lot more about Amper than me.
Well, no, so also the cool part about this was for a brief moment in time in my office, Steven's company and this company, Amper, sat across from each other, right? So this is my one little like future thing is like, hey, there was a moment in time where the two leading AI companies from each end of the spectrum from a technical standpoint worked out of the same room, right? So when Steven talks about they do supervised and rule-based stuff, what he means by that is they have gone out and created a library of sounds that are matched to rules around music. These keys, these progressions, these chords, these notes map to these feelings, these sounds, these instruments, these emotions. And if you go to ampermusic.com right now, you could do it on your phone, you can make a piece of functional music, right? So the company's go-to-market strategy is we're going to replace functional music and stock music libraries with music generated custom for that use in the moment, on demand, right there, right then and there, right, via AI. And their libraries are getting better and better and better and better, and the feedback as people revise and say, that's not good enough, not quite, take the cymbals off, put the French horn on, give me a bigger drum beat, all of that feedback feeds into that model and gives them more and more structure around those rules and allows them to render more interesting music. So what you're about to see here is pretty cool. This is Taryn Southern. She's an Instagram celebrity. She's got about 10.5 million followers, I think mostly in the US and Western Europe. And she went on her own, self-served, ampermusic.com, and made music and made music and made music and revised it and revised it and revised it till she liked what she got. Downloaded the clips, put them into Ableton or Tractor or whatever, and edited them into songs and sang over top. So what you're about to hear is a pop song that she released that's got several million plays on YouTube, has been featured on CNN and Fox in the States, and is entirely, from a musical perspective, created by AI, though edited and arranged, and then lyrics written and sang over top of by a human being. And this is probably the state of the art from a hit song
It is,
standpoint.
yeah.
I wish I could see beyond what I can see. I wish I could touch beyond what I can touch. I wish I could feel beyond what isn't real. I wish I could imagine, yeah. There's more to who we are. There's more to what we could be. As I feel the weight of being, I'm learning how to break free. I'm breaking, I'm breaking free. I'm breaking down, breaking free.
So yeah, no musicians were harmed in the making of that song. It was
Yeah, that's right. No studios, no musicians. Yeah.
no, they just used Amper and sang over the top of it.
Yeah, she did it entirely herself.
That's right. So that's where we're at as far as that approach of music is. It's state of the art of how that might be done. You can see that that approach of embedding the rules into of music and using samples and things like that, it's probably ready for people to start using. My world of no, let's not do that. Let's see if we can learn the rules by just listening to the corpus of music that already exists, that we're probably back to early days. But the reason we checked on that is we've talked a lot about composition, and Popgun doesn't work on composition. We see that breakthrough in Wavenet meant that we could understand music and we can generate it. We can't just generate it, but we can understand it in real time. So what that means is for us, it was game on for a whole lot of new creative tools that can play in real time with musicians. So as you play, I can understand what you're playing and I can play with you. So it's not just composing and staving it, but responding in real time. And as any musician here knows, the best fun about music is playing with other people. And that's really hard when there's no other people around. So there's the promise of this technology was that you can play, that maybe we could imitate what it feels like to play with other musicians, which for learning, I'm told, is the fastest way for people to improve and get better, is to play with others. And for musicians and songwriters to be able to jam at any point you want with another human or pseudo-human AI, maybe lets you uncover new boundaries. We were really inspired by this, by, again, Google's work in the Go. You would have seen that AlphaGo played last year and beat the world champion. It was a feat that everyone in AI said could not be done for 10 years, and they did it in the very first attempt. And the way that they did that is there's a really good blog post where the head Google engineers said that we will never learn to play Go until we learn to play Go. And what he meant by that was, instead of trying to look at the whole history of all the games of Go that have ever been made, that's like looking at a shadow on the wall. It gives you no experience of all of the decisions that weren't made, all of the how was I feeling at any point during the game. None of this information's caught in a transcript of a game. You'll never learn to play the game until you play it. So they went back to the drawing board. They built a new neural net that could learn to play Go, and it was really shit. But they played it played until it got to a very amateur level, and they cloned it. It played each other 1 billion times, and it beat the world champion within a year. So that technique means that you can accelerate that growth. And we were inspired by that too. What we were most inspired by was the response to the only human who so far has played an AI, and that was that guy. And at the response after he lost that at the press conference, he'd said that at times it felt like playing someone who was superhuman, that it was making moves that no one in Go has ever made before. And I've been playing this game for 35 years and now I'm reborn, that I've seen that there's new ways to play. And as musicians, that promise that perhaps there's still music we have never heard, that this can bring us new music that's outside of what we can do, is a fascinating thing to me. And the path to that is we have to learn to play with humans first. And once we are good enough at that, it's game on to see what happens next. And Google guys are doing exactly the same thing. This is a demo. This is
back to Francois in Paris.
Back to Francois, and we're going to hit Francois, who's the very first to do this. And this is like 6 years ago or so. He's programming neural nets to play along with other people. The backstory to this guy, in the last month or so...
He works at Spotify now.
That's right. Spotify headhunted the whole Sony CSL group, and now who knows what they're doing at Spotify. So this neural net's trying to listen and play with him, or what happens next is actually what's happening.
Yeah, this is a continuator.
If you play this, what happens next? That piano's playing itself.
I think it's really cool they got Val Kilmer to film their demo video.
So if you want to learn to play music with somebody else, the first step is you have to be able to predict what they're going to do next. So this is why this is the first problem everybody's working on. And last year, the Magenta team, the Google Brain team, they won the NIPS award for the best demo at 2016. So the NIPS conference is where all of the luminaries in deep learning, not just music, but across the whole industry go, and they compete to have the sexiest demo, and this one won. No one had done this before. This is the end of 2016. So this neural network's listening to what he's playing and going, oh yeah, I know how this goes. I'll play this. So you've got to be able to do it in real time too, which is a huge challenge. So the other music I was playing you before, they'll often spend several weeks running and training the model to be able to produce a single song. This is doing it in sub-second. Which is a big deal.
One thing you'll notice, musicians in here, this is a monophonic response, right? So no chords, just notes.
So that was our inspiration to go to Techstars. We went to Techstars as a young team. They were deep learning guys. I was the music person of sorts who had some connections in the industry. And our challenge was, can we do better than that? And the next step for us was we had to be able to do polyphonic stuff. So could we understand chords and predict chords and play chords and do things like that? So this is the demo we showed on stage. It was much longer. This is only 30 seconds. But this is the demo we showed at the end of Techstars. I'm showing you this because I'm going to show you some other videos that we recorded yesterday. And you'll be able to see progress over the last 4 months for my team based in Brisbane.
Yeah, this is, you got to introduce her.
Yes, we call our AI Alice. It stands for something nerdy. I don't remember what they named it. What you're going to see is Angus is one of our software engineers. He's going to play, and Alice is going to predict what he's going to play next. So, yeah.
Not bad for a 3-month-old.
It was, it was a pretty close run thing. It was pretty close to disastrous run up to it. But
Your version of disastrous and everybody else's version of disastrous are pretty different.
Yeah, so it was...
Bob, it's shit. We can't go on stage. We got to go home. It doesn't work. How about we try again tomorrow?
It didn't work until days before. Anyway, that's where we were at May. So this was last month, and it's call and response still. We're now working with a professional musician, Sean Ferran, who's one of Australia's best piano players, who has helped us tremendously. We quickly got to the point where, are we getting any better? It sounds great to us. Bring him in. Nah, it's still shit. And why is it shit? Because no one in our... Like, I play guitar and stuff, but we're not elite. And he could hear what was wrong with it, where its weaknesses were. So this is about 4 weeks ago, and it's still call and response, and it's only quite a short video. But you'll see it's improved quite a bit.
kind of changed it to meld the two parts together. It's kind of cool.
So we were working towards the moment when Sean was happy enough that, yeah, that's a pretty good response to what I played. That's kind of where I was going. So the stuff we recorded yesterday was no more corn response, our first attempts at can we play together. So what you're going to see is he can play stuff, and Alice will listen, and she'll take that as inspiration and noodle in and around this. So we can do lots with the engine now, but the thing that he wanted to do, and what producers who are talking to us want us to do, is they are trying to use it as a tool for creative inspiration. Can I give it a loop? Can I give it a sound? And it'll play with that. And I just want to sit back. It's like Sean describes it as like I've got a studio musician on call and I can say, now play for the next 6 hours, and I'm going to tell you when to stop.
Nope, not good enough. Nope, try again. Next. Nope.
That's right.
Right, one more time. Nope. Hang on. Let's get some food.
That's
Okay,
right.
try again. One more time.
So you're going to see Sean's now playing. So this was on Monday morning. What he plays is on the bottom, like a representation of keys. Alice is playing at the top, and now it's no longer call and response. They're playing off each other. So this is, he played with us for an hour and a half, and he's just improvising.
It's important to note the top part that Alice is playing, Sean plays, and then Alice iterates and changes it and evolves it, and then he plays the other part below it, right? So he gave her the idea for the top part, and then she continues to evolve it. You should notice some of those, she's playing lead and melody and he's playing harmony. Sometimes he's playing lead and melody and she's playing harmony.
He's a jazz good piano player, by the way. He really loved the idea that he can, in an hour or so, come up with things that aren't songs, but they're bits and pieces of songs that he wants to revisit. And we're starting to get to the point where he goes, can I take that with me now? Can I start to use this?
This is my favorite.
So that's completely unsupervised. It's trained on a whole lot of, about 8,000 classical songs is all it's ever heard. And we take that and we split it into small fragments, millions of pieces. And it's using a causal convolutional net, which means that we are basically turning it into images. And we're looking at it and going, oh yeah, I've seen something like this before. This should be the next bit. And there's some tricks to be able to do it in real time, and there's tricks to be able to do it while the other guy's doing it to listen and play at the same time. It's still really early days, but we've been pretty cool, excited that we've made progress. It feels better than what it was a few months ago, and it's been great to have Sean to come and he comes in every Monday and spends 2 hours with us to play with Alice and to tell us are we getting any better? Because it was a huge problem for us. How do you know if you're getting any better at this type of stuff? Music's completely subjective.
So that's Alice at 9 months old.
That's right. So we talked a lot about composition and collaboration. I'm just going to quickly finish off by just touching on AI's use in a whole lot of other ways. The first is dealing with raw stuff. I'm just going to let this play. The Google team released a product called NSynth, which is a demonstration called NSynth, which you can take sounds and combine it to come up with completely new sounds. And the producers have reached out to us. They really love this idea. They're looking for sounds no one's ever heard before. They want to take a singer's voice and what was it? What did he say to me? I want a singer's voice and I'm going to match it with a Lamborghini and we're going to make something sound completely different. So this is all possible now because we can understand raw audio and start to combine it. So NSynth can take any two sounds and let you blend them in new ways. And you can go online and try it yourself. It's a great demo. And we worked on a similar, this is the very first thing we worked on as a team. I worked in search for so long. Hunted was all about, could I work out what's going to be popular before it becomes popular, and which is a search discovery problem. And one of the core problems was without, as I started talking about at the start, can we do this with raw audio? Can I do it before anyone's listened to it? If I give it everything that's in the top 100 now and I take any other random song, can I tell you the probability that song's going to be a hit? Will it make the charts? I've had so many A&R guys come to me and ask me to do that. And you can't do it. But you can start to do it now. So this is a demonstration of, this is a loop catalogue, 1,000 loops. Can we pick any random loop from there and then find the other loops that sound most like this? This is going to be cool. You're going to see it inside all your DOS and all that other stuff where people are starting to solve that pain in the ass problem of which loop do I play now? I like this loop, but which one's like this? This type of tech will work.
Not quite. Almost there. Next one.
That's
Nope.
right.
Nope. Maybe.
And ultimately, it will become that problem where you'll be able to scan SoundCloud and go, this sounds like stuff that we like. You will be able to define that. We started working on that problem, and it's hugely difficult. And loops works because it's generally a single instrument. It's short, and it's not, in our terms, it's not very highly dimensional. A song is incredibly highly dimensional. When you say that song's like that song, what do you mean when you say that as a fan or an artist? What part's like that part? It becomes a very difficult problem. But with loops, it's quite clear. Just showing there's a bunch of different loops. And then we pick one. This one's finding all the grungy guitars amongst the needle in the haystack stuff. So you're going to see that type of tech start to emerge indoors. We were able to do it within about a month of first starting and realise, well, there's no product here. If we can do it in a month with a bunch of kids from Brisbane, that a lot of other people can do it too.
Well, I think you'll see a bunch of that stuff in the loop libraries, right? You'll see that stuff in other places, which is interesting if you are tracking the growth of those businesses, right? Splice being kind of the leader of that, right? Doing several $1 million a month, like it's a meaningful business. What percentage income increase does Splice enjoy if suddenly their entire loop library and catalog and preset library is searchable by similarity rather than just metadata, right? A lot of what kind of consumption or engagement boost does SoundCloud enjoy if their catalog is searchable by content rather than by metadata, right? So those things will start to pop up. They'll come in, to Stephen's point, where the clips are the smallest and most isolated and the simplest. So there's an advantage for Splice in that sort of category. And they'll come sort of to the organized stereo master pop song catalogs last because it's a computational, it's really heavy lifting on the computational side.
And there's a phrase in the AI world called the AI winter, which we've lived through many times, where AI seems to go "Ruh," and then flat AI, and then "Ruh," and this could happen next as well. So the answer to that question is really hard. AI looked like it was going to do... There's a very famous meeting of the top AI researchers in the 60s who basically said it will work it all out and it'll all be done in the next 6 months. And here we are 30, 50 years later and we still really don't know. So the answer to this question is really hard. It feels like at the moment to people, and it's hard for people like me who work in it, it feels like every time when I wake up and look around, it seems to be moving very quickly, but it could all turn to shit next week as well. So.
All right, so